Alldus podcast is brought to you by Alldus International, supplying your expert AI and digital transformation staffing needs across the US and Europe. Today, you are listening to our AI in Action series, where leading minds in AI from across the world share their story, success, and advice. AI in Action cuts through the hype and explores the true impact of artificial intelligence in our world today.
To AI in Action. I'm your host, JP Valentine. Our guest today is Dr. Jayendra Shinde. Jayendra is the co-founder and CEO at Crosscope. Jayendra, welcome to the show.
Hey, JP. It's my pleasure to be here today.
Now, we're delighted to have you. So, Jayendra, let's start with a brief background of yourself. Can you give us an overview of your journey in technology from where you got started, some of the roles you've held along the way, taking us up to today, and we can then jump into talking about Crosscope.
I'm the CEO, co-founder of Crosscope, a medical imaging startup focused on building clinical workflows and deep learning-based decision support tools for automating histopathology image analysis and assisting doctors in rendering more accurate and efficient cancer diagnosis. I am an academic entrepreneur or an academic who turned entrepreneur. In my previous life, I was a scientist by training. I grew up in India where I did my integrated master's in bioinformatics. With continued interest in computational cancer research, I moved to Paris in France to get a PhD in computational biology. And until recently, I was a postdoctoral scientist at Stanford Medicine. With my academic background and experience in developing tools for analyzing cancer big data, doing medical AI seemed obvious. While at Stanford, I was also enrolled in the Stanford Business School's Ignite program, which laid the business foundations for Crosscope, really. This was more like a mini MBA experience for technical founders to work alongside fellow scientists and engineers to further develop the idea, ultimately pitching it to a panel of investors and industry experts. And during this program, I realized that I could take Crosscope much further than I had first envisioned. The inspiration to be involved in cancer research in my previous roles, as well as to start the venture, comes from a deep concern that a proper oncology solution would not only bring some certainty to families of cancer patients, but it will also open up the path for future fight against this deadly disease. Exploring this idea with my long-term friend and now co-founder Dr. Ketan Bachuar, alongside my clinician colleagues and data scientists, I learned that my background could make a big difference in supporting tech for more accurate cancer detection.
Excellent. And that's a great segue into the origins of Crosscope and the mission. So for anyone not familiar with Crosscope, can you give us a high-level overview of what you're doing at Crosscope, what the mission of the business is, and then we can jump into the role that data science and AI is playing in achieving that goal?
Absolutely. So Crosscope, it's an abbreviation for Computational Microscope. We are a medical AI software company on a mission to radically transform patient care by unlocking the power of AI. Our Crosscope DX software is a digital pathology platform to facilitate deploying scalable artificial intelligence and computational pathology tools to empower pathology laboratories with precision diagnostics. Our team of engineers, data scientists, and pathologists are developing a unique platform and AI approach to deliver efficient clinical workflows for increased diagnostic accuracy and productivity. Our goal is to facilitate deploying scalable artificial intelligence and computational pathology tools to provide a better standard of care for individuals around the globe. We are a company of 8 full-time and 12 part-time employees across 2 offices in the US and India, led by a management with PhDs and extensive experiences in the fields of cancer research, deep learning, medical imaging, and digital pathology.
Excellent. So thank you for the overview, Jayendra. A lot of what you're doing is focusing on AI for pathology, which is quite a complex space, but there's so much opportunity for real advancement. Can you give us some insight into what that means for anyone who's not familiar with it, and talk us through the main goal in using AI when looking at pathology?
Yes, JP, before jumping to AI for pathology, I would like to take a moment and highlight what is pathology, because not a lot of people, unfortunately, know this field of medicine. So when a cancer is found on suspicion by a radiologist, a surgical biopsy is performed that involves surgical removal of tissue from a lump or mass for examination. So pathology is a very central aspect to diagnostics and a field of medicine which is related to diagnosing a disease mostly through analysis of tissue cells of such biopsies. The lab process involves pre-processing of these tissues, creating thin sections, putting them on glass slides, staining them to visualize and characterize these cells under the microscope. This process of visual assessment is the gold standard for most cancer types and then determines the treatment plans for each patient. That is why this field of medicine is central for decision making in every cancer patient's clinical journey. Now comes the digital part in pathology. So digital pathology is the technology that allows to scan these glass slides and replace the microscope with a computer screen for assessment. Not only does it remove the discomfort of viewing under microscope for hours and provides the convenience of dealing with images instead of glass slides, but by digitization of glass slides to images, unlocks a lot of potential to automate many tedious, time-consuming tasks.
You are listening to the Alldus podcast. When you're looking to scale your team, or if you are interested in showcasing your company in a future episode, reach out today. Or if you're in the market for a new role, visit our website to view open positions, www.alldus.com.
Staying on the topic of digitization and AI, what are some of the main hurdles in the field that you face? And can you give us some insight into what it takes to overcome these hurdles?
Absolutely. So there are some major hurdles in the field of pathology today, and artificial intelligence can definitely add value and support pathologists, given the exploding number of cancer cases and shortage of expert pathologists. Last year, a total of 20 million cancer cases were diagnosed, and the world currently does not have many expert-trained pathology eyes to screen through all those tissue slides for providing timely diagnosis. Another bottleneck is quite technical in nature. Unlike other medical imaging modalities, we deal with high-resolution gigapixel images, which are billions of pixels in size, ranging from 1 to 5 gigabytes in storage memory. We can imagine manually performing visual assessment of such large images is like searching through Google Maps without any landmarks for finding cancers. The sheer vastness of these images makes applying traditional computer vision applications quite challenging. So a pathology AI system is a computer program that assists pathologists in their work by providing some form of automation. The key capabilities of a pathology AI system is to analyze digital slide images of these tissues using image analysis and artificial intelligence techniques. AI allows to learn a task from data and perform pattern recognition on those images, like providing a diagnosis or a score, or a subtask like classifying cells into different cell types.
So you talked about medical imaging and the role AI can play. What do you see as some of the opportunities in utilizing AI for the automating process of these medical images in terms of speed and accuracy, and how is that going to impact pathology and medicine in general in the years to come?
Great. So artificial intelligence has started impacting our world and our lives. A rapidly growing number of businesses, also including healthcare particularly, are adopting artificial intelligence to reduce their operational costs, improve customer experience, in terms of healthcare, improving patient lives, and also to generate new resource revenues. The intersection of medicine and AI is really not a new concept. AI in medicine even goes back to early 1960s with Eliza, the very first chatbot, which was a conversational tool which recreated the conversations between a psychotherapist and a patient. So artificial intelligence is one of the hot topics in medicine, especially in medical imaging in recent years. Research papers are published every month investigating applications of machine learning in medical imaging, from image acquisition to image interpretation and prognostic evaluation. Deep learning rose to its prominent position in computer vision when neural networks started outperforming other methods on several high-profile image analysis benchmark studies. Most famously on the ImageNet large-scale visual recognition challenge in 2012, with a deep learning model, a convolutional neural network halved the second best error rate on the image recognition or image classification task. Enabling computers to recognize objects in natural images was until recently thought to be a very difficult task, but now with convolutional neural networks, we have surpassed even human performance. So the promise of AI, of course, that the technology can, in its first iteration, make all of us in healthcare, particularly clinicians, researchers, administrators, and also patients, more effective and efficient by automating routine tasks. The promise of AI in imaging field is to deliver savings, particularly on two fronts. Number one is productivity aspect with time savings and resource optimization. For instance, AI can automate the routine reading and interpretation of medical images such as X-rays, CT scans, and now pathology images, exceeding the accuracy and reliability and certainly the stamina of even the most expert clinicians. Number two is the quality aspect with accuracy and perception gains with focus on precision health approaches. Such quality aspects of AI can alert clinicians on newly available knowledge in considering their diagnostic and therapeutic decisions. It seems that the initial AI promise of savings will be delivered on the productivity front, whereas the second aspect of quality savings will probably take a long time to catch up. This also is attributed to the lack of appropriate metrics to measure outcomes and resultant quality savings, which is relatively easier to measure from a productivity standpoint. So the greatest opportunity with AI in medicine is aptly described by Dr. Eric Topol in his book, Deep Medicine. He says AI systems can free healthcare providers from routine, repetitive tasks and help return to humanism. By this, he means AI can restore the human touch between patients and doctors to provide empathetic, compassionate advice and feedback to patients instead of being distracted by frantic data input into electronic health records and other applications.
Yeah, really powerful quote and so accurate. Final question from me, Jayendra. You've given us so much insight into the potential impact AI can have within healthcare, the medical field, from pathology to imaging, the automation side. Looking specifically at Crosscope, when you look ahead, particularly over the next few years, what are you most excited about the future of Crosscope and the impact you guys can have on this industry?
Great. With the rise in recent digitization in healthcare, the field of pathology is also undergoing transition now, and we are quite excited about it. So Crosscope's aim is to really fundamentally lead this digital transformations for pathology departments and diagnostic labs all across the globe by facilitating deploying scalable artificial intelligence and computational pathology tools to provide a better standard of care for cancer patients and improving patient outcomes. Our goal is to build a flexible digital pathology ecosystem with a portfolio of AI modules for pathologists and cancer experts to choose from depending upon their clinical practice and workload to positively impact their patient lives.
Jayendra, thank you so much for coming on and talking to us today. I really appreciate you sharing your story, giving us the background and the mission of Crosscope, teaching us about the impact of AI for pathology, medical imaging, and what the future holds for this space. We wish you and everyone at Crosscope all the best of luck in achieving your mission, because it's going to benefit us all. So thank you again, Jayendra. Really appreciate it.
Thanks for having me, JP.
Thanks for listening to this episode of the Alldus Podcast. If you enjoyed today's episode, don't forget to subscribe, rate, and review. We are available on Apple Podcasts, Spotify, and any Android podcast of choice. You can also head over to our website, www.alldus.com, to listen to more podcasts, view our open roles, and stay up to date with industry news. Thanks for listening, and stay tuned for more great episodes coming very soon.